All know that waste management is a real problem in cities. So I thought, why not turn this into a graph problem? That's how EcoGraph was born. Hello everyone. This is EcoGraph, my solo project developed by me. It is basically a smart waste management and route optimization algorithm. It simulates how waste can be managed through algorithms and works online, just like food delivery apps like your Zomato and Swiggy, where a user can place a request for waste collection and disposal. So it is basically a prototype. So let's go through a quick walkthrough out, and I will be showing you its features, the system architecture and the data flow diagram. This is the system architecture of EcoGraph. The user interacts with the web interface built with HTML, CSS, and JavaScript, where they can select modes like FIFO and priority. I will be showing you these modes. The request is then processed by either local C++ Dijkstra backend or Flask Python backend, and the optimized route is sent back for the animation on the Cytoscape library. Now, this is the data flow diagram. The user selects home location, waste type, and the mode. The system first classifies the waste, then runs the route optimization module, which decides whether to use C++ backend or Python backend. Finally, the output is generated and as an optimized route, and starts the visualization. So let me explain you how this web app works. So first, user is going to select any home from the given map. Like for example, home 4 is being selected. So home 4 wants to get its plastic bottle disposed. So user also have to enter the waste description, and then user is going to click on add to queue. So it is like there can be multiple homes requesting for the waste disposal at the same time. So to deal with that, I have created a queue so that if there are more than uh, uh, two or more than two homes that are requesting for the waste disposal of different types, then that can be added to the queue. So for example, here home 2 wants to dispose its broken phone. So home 2 has requested to dispose the broken phone, and then there can be multiple homes existing in the queue. There is no limit to that. And then when I click on classify and route, then it is the route is being calculated, and it is being shown as an animation with the help of JavaScript. So in the backend, it is basically calculating the shortest path with the help of Dijkstra algorithm, and it is disposing the waste according to the waste classification. Like for the plastic bottle, it is disposing that in the plastic bin, and for the broken phone, it is disposing it in the electronic bin. But here's the catch. Now, what if someone wants that the truck depot should collect waste from all the homes at first, and then dispose in the in their respective bin after that? So for that, I have created a FIFO mode: collect all first and then dispose. So I'm going to refresh it, and then after that I am going to enable this mode. Now once this mode is enabled, then after that, if two or more than two homes give a request for the waste disposal, like for example home 4 again gives a request for the plastic bottle disposal, and home 2 gives a request for the broken phone disposal, then after that, when I click on the classify and route, and there will be another logic running in the backend. It will be like Dijkstra only, but in the different way. The truck depot is first going to calculate and collect waste from all the homes at once, and then going to dispose them. So let's see. So here the backend algorithm is giving the shortest path, and then like you can see from home 4 and home 2, the waste is being collected first, and then after that it is going to be disposed. And here route status is also there, it is going to show that how much distance is traveled, and how much time it will be taking for that. And there is a sign which is showing that which color means what. So this is all about the feature of the web app. It is a simple web app which is basically a prototype, uh, which shows that how real world issues for waste management can be solved with help of uh, algorithms and technology. Now let's jump into the coding part. So this is the code for the project of EcoGraph. I have basically used Flask, Python, and C++ also. I will be showing you how. So I have created a graph for the Dijkstra, and I have created some functions like for the FIFO and for the priority immediate basis, which is the default mode. And then there is an route optimization algorithm, and there is a classification algorithm. It is basically simple if else, and there is a Dijkstra. So here's the thing. I have created two types of backend logic. The first one is in Python only. So here as you can see it, Dijkstra shortest path algorithm for web hosting. For when the website is running online, then this Python logic is running in the backend, but I have learned DSA in C++ language. So I wanted to implement that in C++ only. So to do that, I have used a sub-process library, as you can see it, but I have commented this part since this thing is not working when the web app is hosted. So when the web app is running offline, then C++ code is being running and being rendered. Like here you can see it. The logic.exe is being running in the backend. So it is the code in C++. It is basically I am sending the path details from the Python to the C++ code, and then here in the int main thing, it is going to it is taking that as an argument, and then after that there is a sample graph, and then Dijkstra algorithm. I am running the Dijkstra algorithm since I have learned that in C++ only. So there are two type of backend logics. The first one is in Python only in the Flask, and the second one is in C++ through subprocess library. So that's a very unique thing which I found. So this is all about my project. If you are having any feedback or any suggestions, then feel free to comment. Thank you.